So today we have James, special guest. So James, can you give a brief overview about yourself? Usually people have like a 10-second overview, so maybe you could say a little bit more.
Hey everyone, my name is James. I do content on like algos, like alpha code. We like to do coding interviews, spam leak code. I don't know. This is fun stuff. So we just got in this community, and yeah, I don't know. We work at fan companies type thing too, but we just like that's how I kind of got used to doing leak code, was just actually studying for interviews. And then I realized that, or I just got bored of just doing it all by myself all day. So I started posting as well, just to make it more fun. And now I don't know, it's way more fun when you're interacting with people and there's a community around it. So hopefully you can keep it up.
Yeah. I mean, I made my channel because I just wanted like accountability, because I was like, I want to make sure I can do stuff, so I'll just make a channel and make videos and stuff. Okay.
Yeah, and like teaching it is a way different skill. So you could
Yes.
talk. That's one thing I noticed too, is when I would just learn this all by myself, then I went 2 years without even coding or without even doing leak code. I forgot everything I knew, and it sucked. But now I could always just go back on my videos, and then
Yeah.
I'll never forget anything I knew, and I'm just gonna upload everything I ever learned.
Okay. Okay, so let's get started here. So today, how familiar are you with like heaps and like how a heap is made?
Uh, Pretty familiar. I
Okay,
mean,
let's
yeah,
see.
I'm like
Let's see.
familiar enough, I guess. Don't want to sound cocky.
Sure. So what we're gonna do is we're basically gonna implement a max heap in Python. And so the functions that I want you to build for a max heap is heap push, heap pop, and that's it for now. And then make this in a way where, like, imagine this was actually like a production system. So you like, have the right stuff exposed, have the right internal stuff, things like that. And then we'll have some follow-ups, but so far this is a good place to start.
Make it a production system. All right. Okay, can I start coding? I'm just kidding.
Yeah.
All right. So we're let me think about this a little bit. We're gonna implement a heap, and it's gonna have two functions, a push and a pop. And we want it to be production. So we want it to be a max heap, right?
Mm-hmm.
So with a max heap, the heap invariant is going to be every parent is greater than children, right? And that is applied recursively.
Mm-hmm.
And yeah, so we're probably going to want to, let me think. What kind of values do we want here? Is it just integers? Is it
So I think for now, let's just have anything that like a normal heap can handle. So I think in Python, you don't have to provide a type, right? And you can just do like less than and greater than and stuff. And like anything built in that has a less than or greater than should work.
But all the elements should be comparable.
Yeah, so they should all be the same type, but the type can be, integer, string, whatever.
Okay, so it should be generic. Should be generic.
Mm-hmm.
But it's gonna be like when we create it, it's gonna all be the same, all be the same element, or
Mm-hmm.
all be the same type, so it's comparable.
Yeah, so you can assume it's all the same type. Like, I guess in a real production system, you'd probably have some kind of typing thing, and then it would just like error out if you implemented it, but we don't need to do
Yeah,
that here.
yeah. Okay, so yeah, so the heap push is probably similar to insertion. So what we're gonna do here is usually with a heap. The way that I'm thinking of implementing the heap is using a array, because it's supposed to be a complete binary tree.
Mm-hmm.
So it's a complete binary tree.
So what does a
I want to
complete
use
binary tree mean?
it pretty much means, well, it's like semi-fill. So a complete binary tree is every node, every level is full.
Mm-hmm.
But this one, every level is full, except maybe the last one. But we'll fill the last element from left to, or the last level from left to right.
Yeah, so it's like it might not be completely full, but you're always filling left to right. So you never, if you're
Yeah.
going left to right, you'll never have a gap. Yeah. Okay.
Yep. We'll never have gaps. So that works good, because then we could just we'll use, instead of implementing nodes, we'll use array, as the state.
Mhm.
And essentially, yeah, since we're going to be using the array as a state, when we insert, we're pretty much going to push to the back of the heap. And we can go into the drawing and show what I want to do here.
Mhm. Oh yeah, we can do the drawing. That's fine.
Just to make sure I have my thoughts.
Mhm.
So pretty much we're gonna be able to like insert 5, and we're doing a max heap, right? So
Mhm.
the largest bubble up, we'll do like 1, 50. So with the insert, what we're gonna do is we're gonna be using an array. So when we'll just push 5 into the top, but it'll essentially bubble up. It'll look like a binary tree.
Mhm.
Then we'll put 1, and it always goes into the next neighbor. So 1 will go here,
Mhm.
and then when we insert 50, right?
Mhm.
When we insert 50, it's actually we have to insert into the next available slot, but then bubble it up. So we need to be able to figure out the parent so that we can bubble it up. And if this was a longer, like a bigger tree here, we'll need to bubble it all the way to the top, swapping with the parent. So we just need to figure out how we're gonna locate the parent in the array, and we could do that using by just doing some math, because it's going to be a complete binary tree. So
Mhm.
essentially, you're going to look like this. These are the nodes in the array,
Mhm.
right?
Yeah.
So if I need to find my parent, 1, 0, 1, 2, 3, 4, 5, 6. I just need to derive it real quick,
Sure.
because I think the main thing I just need to figure out now is how I'm going to find parent and how I'm going to find child, parent
Mhm.
and child, because when we insert, we're going to have to bubble up. And
Mhm.
then when we remove something, we need to swap the top element with the last element, and then bubble that down.
Okay.
So with the parent, so 3, if the parent is 4, what can we do? We could just do like the index divided by 2. That'll just give us 3 divided by 2 equals 1. 4 divided by 2. No, that won't give us 1. So what we need to do is 4 divided by 2 minus 1, or the ceiling minus 1. Okay, wait, let me figure this out.
Mhm.
Because 0, 1, 2, 3, 4, 5, 6. Okay, so the parent is like some divide. If you divide 5 by 2, you get 2.5.
Mhm.
2.5. But if you do 5 divided by 2, you get 3. Right? That's bad. If you go 3 divided by 2, or 3 divided by 2, you get 1.5. 4 divided by 2, so it's 1 off. So I think we just need to take the ceiling and then minus 1. This will 2. This will be 2 minus 1. So I think we just take the ceiling of index divided by 2 plus, and then add 1, because
You
1
mean
divided by
subtract
2 is,
one?
yeah, subtract 1.
Okay. Yeah, makes sense.
It's kind of weird. Index divided by 2 plus 1. Yeah, because this will give us 3, and then, or minus 1. This will give us 3 and then minus 1. 1 divided by 2, 0.5. Take the ceiling. Yeah. 2 divided by 2 is equal to 1 minus 1. Yeah, that should work.
Mhm.
Okay, for the child, let me figure out how we're going to do the child. 1, 2. Maybe, do we just double it and plus 1? Yeah, I think for the left child, we go index times 2 plus 1.
Mhm.
And then for the right child, we go index times 2 plus 2.
Okay. Yeah, I think that makes sense.
1, 2. Yeah. Okay. And then yeah, pretty much that's so what we said is for pushing, we're gonna bubble it up, and then popping, we swap with the top element and then move it down, and I'll use this
So when you say you swap with the top element, like let's say this was your heap. Let's say you actually had this like obviously this is like a min heap, but or whatever. Let's say these are your nodes, right? These are your
yeah.
indexes of your nodes. So can you explain like what a pop would look like?
Yeah.
Like what do
Let's
you mean
go
swap?
we'll -1, right?
What do you mean -1?
-1. We add -1. It needs to go to the next element here. So since we're looking at a min heap right now because that's how it's structured.
Uh-huh.
And then what we do is if we want to, oh, you want to move it down. We want to pop it, right? Okay.
Yeah, so like let's say I'm popping the top. So I'm popping
Yeah.
this. So what
Yeah.
does that look like?
So when we pop, what we're going to do is we want to maintain like the complete binary tree. That's why we kind of swap it.
Mm-hmm.
And then we could just like remove this. So that is our element now.
Mm-hmm.
Now our heap invariant is messed up. 8 is larger than the values under it. So
Mm-hmm.
what we need to look at the left and right and swap with who's smaller than us. Because if I choose the one that's smaller,
Mm-hmm.
then it will maintain the invariant. Because if I choose the one that's larger, then it's going to be larger than the one to like the other sibling.
Yeah.
Which breaks the property. So we swap 8. We look for the one that's smaller. We swap 3.
Mm-hmm.
And then eventually gets down, and you could just see that the invariant holds where every single element is smaller because this version is a min heap. Every element is smaller than its child.
Okay, got it. Yeah, so I think both of these make sense. So yeah, do you still want to stay in the drawing, or are you good to get out of this thing?
Yeah, I'm good to go.
Okay, so yeah, so you're gonna have a heap pop and a heap push, and basically you said for the pop you'll do a flip, and then you'll get rid of the last guy, and then you'll bubble down.
Yeah.
For a push, you'll insert in the end, and you'll bubble up. I think that all makes
Yeah,
sense to
exactly.
me. So let me ask you, like, what kind of functions are you gonna have here, and then what should be like user exposed?
Yeah, so we're probably gonna want to have like a constructor,
Mhm.
and that's gonna initialize the state. We don't want them to actually access the state. We want to hide that behind. And then probably we'll just want the heap queue or the heap push and a heap pop.
Mhm.
Right? So that will put elements, and then heap pop will get us. And then maybe if they want to just look at the last element like a peak, but that's not part of the requirements. But
Mhm.
essentially, we just want the constructor and these two, and we want to hide all the implementation details,
Mhm.
like, and hide everything. But in Python, it's kind of hard to, you can't really define private variables.
Yeah,
like
so
that.
let's pretend, you can mark it like whatever, is it like double underscore or something? We can do something like that. Or you can just write private over it and like in another language that you could easier, and like that's totally
Yeah.
fine. Okay, so let me ask you one last thing. So for the heap pop and the heap push, what's the time complexity of those?
It's gonna be log n or log of the height or log n,
Where n
which
is
is pretty
what?
much n is the number of elements in the tree or in the array.
Okay, got it.
Yeah.
Okay, yeah, I think so. This looks good to me. If you want to write anything else, you can, but feel free to
Okay, sounds
start
good.
writing it.
How are we doing for time, by the way? Just want
So
quick time
we
check.
stop at 1:10, so we actually have about 50 minutes, so we have a lot of time.
Okay. All right.
And I
So,
will have follow-ups, so
all right, sounds good.
yeah.
So we're gonna have a heap class, and then we're gonna have our constructor. I don't even know how to spell that. And then we're gonna have heap push, heap pop, right?
Uh-huh.
All right. So, like I mentioned, in our heap, we're just gonna have an array. We'll just call this the state for now. We'll figure out a better variable name. But what we're gonna do in the heap push, and then we're gonna do push, and we're gonna get like a value. Honestly, I don't really run types on Python like that, but it'd be like,
It's fine. Yeah. Like honestly, that's why I think this question would be better if someone did like something I knew, like Java or something. because then you can type
You
it
do
instead.
Python though, right? I thought you
Yes,
do
but
Python.
I don't know how to type Python because I mostly use it for
okay.
DSA as well. So
Yeah, return. So this kind of returns. I usually just vibe code the types, return the
Yeah.
value. So what
Okay.
we said, what we're gonna do when we heap push is add to the array
Mhm.
at the end and bubble up.
Okay.
And then what we said for the heap pop is we swap with what are we gonna do? Swap with last element
Mhm.
and then bubble down,
Mhm.
right?
Yeah.
So what we're gonna do is we're gonna figure out we're gonna add to the end, and then we're gonna figure out our index, and then we're gonna have to figure out. It might make sense to build out functions for getting the parent and children,
Okay.
but or we could just like hard code that. But let's just go through this first.
Sure.
We're gonna go self.state.append the value. This adds to the end, and then the current index is equal to self dot, pretty much the length of self dot state
Okay.
minus 1. And then we'll say while the index is less than equal to or greater than equal to 0,
Mhm.
because the zeroth element is the top.
Mhm.
So while we do this, what we're gonna do is grab our parent, and then let's just define the parent here. Define parent.
Okay.
It's probably a private function that no one needs to know about.
Mhm. So maybe you can mark it as like underscore or have a comment or something just so we're clear like what's exposed and what's not.
Yeah, should be. There's probably a way in Python. I'll just have to look it up after.
I think
Or
you
hit
can do the
AI
double
assist.
underscore. Yeah. I think double underscore in front of the method. I feel like that's what it is. But
Double
I think
underscore?
there's like hacks. Yeah.
Yeah.
There's like
Could I
hacks
ask the
around
AI
Python.
assist here or no?
Yeah, definitely. I don't think this is
Okay.
important. Feel free to. Yeah.
I'll ask that.
You can ask it at
Actually,
the
yeah.
end as well if
Yeah,
you
I'll
want
ask
to.
that then. Yeah.
Okay.
The parent left.
Yeah, I feel like that's like good use for AI assist where it's like some small thing, but you're not like solving the problem with it. So
Yeah. Like, how do I make this thing private?
how do I like have types? Like if I want a generic type or whatever, stuff like that makes sense.
Left child, right child. So we have a left child and right child, and let me just go into the drawing again and just extract out this.
Sure.
So it's okay. We're gonna have to import math.
I think Python, you don't need to import math, or at least this coder pad, you don't need to import math, but that's
really?
fine. Yeah, if you just call seal, it'll work.
Oh, nice. So here we do index divided by 2 plus 1.
Mm-hmm.
And then here for the left child, we do index times 2 plus 1.
Okay.
And then here we do index plus 2.
Okay, cool.
So what we're going to do is we're going to get our parent, self.parent. This is the index of our parent inside the array index. Mm-hmm. And then we're doing a max heap, right?
Yeah.
Max heap. Keep forgetting. So essentially, let me just draw a quick tree at the bottom. Sometimes it's hard to just make sure understand how we're bubbling.
For sure. Yeah.
So we push 1, 2. So we're gonna bubble up. We locate our parent, and that's just the index. So we say if the parent, or if the self.state, and like you could also like implement a way to hash and be able to grab values from the state, so we don't have to do self.state. But I have to look that up. That's like better design. But if self.state.parent is greater than or equal to, or if my current index, if the val is greater than or equal to the parent, what we're gonna do is we're gonna want to swap them, and
Okay.
then the index equals the parent. But what we're gonna do is self.state of that index. And it gets a little bit tricky. We could just do in place like this.
It's funny, I learned in Rust and C++, there's like an array swap where you literally just put in the two indices and it swaps for you, so you don't have to do this crap.
That's clean.
Yeah.
So the parent goes to the parent. We swap the parent with the current index, and the parent. Yeah, that works. And then the index becomes the parent.
Mm-hmm.
Else, we're just gonna break.
Mm-hmm.
Right. That will kind of bubble us up, and then there's no return value. Something like that. And this val is just the same, so we don't need to actually just keep extracting. We just know that value is what we're bringing up.
Mm-hmm.
So if the value is greater than, okay, what's the other case? The other case is it's less than. So if the val is less than, we just break, and then nothing changes.
Mm-hmm.
Okay, I think that's fine. Now let's move on to actually doing the swap or the heap pop.
Okay.
So what we're gonna do with the heap pop, it's pretty similar, but we might have to copy and paste that code. But what we're gonna do is we're gonna swap the last element with the first. So we're probably with this, we probably want to like throw an error if it's already throw error. If like with a lot of these, we want to have low validations like that. But like if the length of self dot state equals 0, throw or raise something. I don't know. I need to look that up. Raise empty. I need to look up how to actually raise an exception. But essentially, what we're gonna do is swap the last element with the first. So we're gonna do something like this. So the 0th index is going to swap with the last index, and the last index is going to swap with the 0th index.
Okay.
And then the return value is going to be self.state.pop. That's going to get us the last value that we eventually return. And then we're going to bubble down, right? So we pat the 0th becomes the last element. Yeah. So now we're going to bubble down. So we're going to start at the current index. And that's going to be equal to 0. And we'll say while index is less than the length of self.state, we're going to want to kind of perform that same logic. But we're going to look at the left child. Self.state. We'll do left child. So we'll do. Is everything making sense so far on the implementation?
Yeah, I get it.
All right. So we're going to do left child and right child. Now this part's going to get a little bit tricky because we need to figure out who we're going to swap with.
Mm-hmm.
So there's going to be a few cases. If left, or we need to figure out who's the smaller child. But like if we're going to get the current value. Yeah, we need to grab the current value equals self.state at the index. So it's going to get, this might get tricky here. So we're going to get, and I'll delete these comments after, but So max heap, right? So 3, let's say 3. So now like 1 has to kind of bubble down, but we also need to deal with like neighbors. So suppose this is 4, or this is 4.
So this would be a min heap, right? Or yeah.
Or this is after we pop, right? Pretend 1 got to the top.
Oh, okay.
And then
Oh,
this
I
is a
see.
max
Okay,
heap. Like
max heap. Yep, got
suppose
it.
this was like a 5 and maybe 1 was at the bottom, but
Got
like
it,
now
got it.
1 got here.
Mhm.
So it's a max heap. We need to look at our left and right child and figure out which one to swap with. So if the current val is greater than or equal to left. So I'm just going to extract the values now.
Okay.
Right val. So essentially, like if the current value is greater than or equal to both the left value and the current value is greater than or equal to the right value, we could just break.
Okay,
it's in the
makes sense.
spot. Elif, like we know it needs to swap. We need to be like Elif. We know that it's greater than 1. Then we could just say if left val is greater than right val. Okay. Then we need to swap with the left. Swap with left. And then last case, swap with right.
Okay, yeah.
So if the left val, because we want to bubble up the largest element. So how are we going to do this? We're going to pretty much have similar logic to this. Okay. And we're going to, so basically our current index is going to swap with left child. This should be left index, but. And then the left index is going to swap with our current index. And then same thing, but we're going to replace it with right. And then, so swap with left. So our current index, then our current index actually equals, since we swapped with the left, this becomes left. So. And then for this index, it becomes right.
Okay.
Yeah, that's pretty much it, because it's going to hit any of these conditions. So it pretty much bubbles it all the way down.
Okay. Yeah, I think this makes sense. So let's, I'm trying to think like how we could test this. Like, what are your thoughts on how we could test this?
Yeah, what I can do is like I can just quickly implement like a top K. Like I'll just make an array and then I'll try to figure out the top K in it.
Okay.
So we can start with like array equals 1, 2, 4, 3, 5, 2. And then what we can do is we can have our heap. This could be like wrapped in a test function, but maybe we could just do like a heap. So the heap starts off with nothing. And then what we can do is for element in array, what we're going to do is for element in array, what we're going to do is heap push the element.
Okay.
And then we're going to have to implement like the size or the length I think it's just like a dunder method for length. I'll go up here and implement this. So.
Okay. Oh, if you want to call like len, I see.
Yeah, exactly.
Okay, got it.
Return self length of self dot state.
Mm-hmm.
Something like that, or its size. I'll just implement both just in case.
Okay. You can also use the AI for this one. This seems pretty reasonable.
Okay. And then like I'll also implement representation because
Yeah, I think
that's how
that's a
you
good idea.
representation. Oh, then we'll just do or we'll just do join.
Mm-hmm.
Dot join self dot state, something like that. Or that might not work because it's what we're gonna do is we're gonna heap push if the length of, let's just set k equals to 2.
Mm-hmm.
If the length of heap is greater than 2, then we'll do heap dot heap pop.
Okay.
And then at the end, you could just like print the heap, and it should just contain 5 and 2.
Okay. Yeah, I like it.
If it works correctly. Let's see, list on index. Okay, now we're already hitting some bugs. Now we gotta debug.
Mm-hmm.
So we're at 72.
Mm-hmm.
Yeah, we're not capturing these corner cases.
Yeah.
If the parent is greater than, well, we can just return this here. Wait, parent is out of bounds. Greater than 0, because we don't want to. Once it gets to 0, we don't care.
That's right. Okay.
Okay, let's look at the if. Where is it? Where is it breaking now?
Looks like, is it 72 again? Or is it something else?
Let me usually I'd use a debugger, but I'll just like print parent.
Mm-hmm.
So 2.
Wait, why do we have all the hello worlds? Maybe we can get rid of that as well.
Oh yeah. Okay.
Yeah, let's get rid of that. Okay.
Okay, let's just do a simple. Okay, so I'll just add some prints quick, and I'll delete this eventually. Pushing. And let's see where it breaks.
Okay.
So it pushed 1, it pushed 3,
Mm-hmm.
and then when it pushed, why didn't it push for? Wait one sec. Push element with the invalid escape. What is this? Okay, let me delete some stuff.
I think it's like if you have an invalid character in a string is the error. Okay, now it's gone, so that's good.
So it pushed 1, it pushed 2.
Mm-hmm.
It pushed 1, it pushed 3. Okay, then it broke on 2. So let's just debug what's happening here.
Mm-hmm.
Index. So we add the value. Push 1, push 3. Okay. We're pushing 3. And it breaks on 3. 0, 1, 2.
Well, there's a 2 as well. So what? Oh, so it breaks on 3, and
Yeah.
this is the thing it breaks on. Is the parent is 2, I guess.
Index equals the length of the state. So it's 2 minus 1.
Mm-hmm.
What's the parent? Let's do it like this. Oh, I did it minus 1.
Oh, okay.
It's supposed to be plus 1. Yeah.
Oh, wait, is it supposed to be plus or minus? Minus?
Yeah, it's supposed to be minus 1. Ceiling
Okay.
minus 1.
Okay, so now it's breaking. Yeah, so this is the one that this is the one I noticed when you were coding.
Okay.
Didn't notice the other one.
there's gonna be some 104 heap pop. So all the pushes is working properly.
Mm-hmm. Yeah, it seems you are familiar with a stack trace, unlike some people. So that's good.
Let me remove the push. Or like the state. When I'm printing the state.
Oh yeah.
Okay, we're pushing 1 1, and then on the first pop, line 83.
Yeah. Maybe you can
Yeah,
get rid of this
because
parent
it's
too if
gonna
you
be out
want.
of bounds. Yeah.
Yeah.
Which parent? Oh yeah. This
The
is
parent
stupid.
print. Yeah.
Yeah. So this is, it can grab a right child that's out of bound or a left
Mm-hmm.
child that's out of bounds.
Yeah.
We just need to, like, I wonder how I'm gonna handle this. I'm gonna just return a -1. Wait, if there's a clean way.
There is a clean way.
Yeah, I might return -1 or in like a float infinity or something.
Yeah, I think
Or
that would
float
make sense
negative
to
infinity.
me. Either like return like something you would never swap or -1 or something, and then you can just keep all your same stuff.
So if the right child, so if the left child is greater than, because we're looking ahead, because we're adding, is greater than, equal to the length of self.state, then we just do infinity.
Mm-hmm.
Negative infinity, maybe. Yeah. Wait, I'll worry about that in a sec.
Mm-hmm.
If it's negative infinity or positive. If the current value is greater than, yeah, it's going to be, if they're both empty, like we're at the end, if it's greater than left val and greater than, it's always going to be greater than infinity, so we're good.
Okay, let's try that. Type error.
Yeah, it's because this thing is joining on like a.
Oh, I see. Yeah, that's right. I think you need like
Let's
an
convert this to string.
Okay.
Should return 2 and pop.
Nice. So so your join just needs to join on like a space or some kind of thing. Right now you're just combining. Okay, so we wanted a max heap, right?
Yeah, this is a max. We wanted a max heap. What did it return? It returned a min heap.
Oh, you got a min heap.
All right. What's going on here? If the current value is, okay, my current value is greater than. Wait, what did I say?
So I think your test
swap it.
is just incorrect. Like I think the code is right, but because you keep popping the max, you will get the min. So I think this is actually correct. Does that make sense? Like when you get 135, you'll actually pop the 5. So I think this is actually, yeah, this is like, because normally you do top K with a min heap, so this is like bottom K and like reverse. So I think this is fine.
Yeah, you're right.
Okay, so I think, okay, so we're gonna have one more function and we'll see how far we can get here. So are you familiar with how Heapify works?
No, not really.
Okay, so I can explain
but
it.
We can figure it out. Yeah.
Yeah, so do you know the time complexity of Heapify?
No.
Okay, so Heapify,
Again?
no, so Heapify is actually linear time. So you can take a heap and you, and it's a linear time thing. So that's why it's always better to like make an array in Heapify instead of like adding elements with like a heap push all the time. Because if you add a million elements and then you do a Heapify, it's O of n. If you heap push them all, then it's n log n. So let's say we just have a bunch of random numbers, like just say we like 5. Oops. How do I delete? Okay. I think I have to like zoom out or something. Okay. So let's say I have like 5, some random numbers, 3, 1. This is like my random array. And this is what it looks like. So basically the goal of Heapify is to turn this into a heap in linear time. So can you think of like, do you have any ideas of how we could do that? And then maybe I can give you some hints.
So you say we're gonna like throw it into a queue right away, or we like start it? We just start with a random tree essentially, and then we want to convert it in like heapify that tree.
Exactly. So I can just take an array that would just look like 5, 3, 1, 4, 6, call Heapify on that, and that would turn it into my max heap.
Yeah, like one way that I'm thinking is we just like start trying to we start at each index and we try to get it into the right place, and maybe it amortizes to O(n).
Okay. Okay.
So
So
like maybe
how
like
can you do that?
if this is a max heap, right? We swap.
Mm-hmm.
First, our goal is to get this to the right spot.
Mm-hmm.
So like it swaps here.
So it's a max heap. It wouldn't swap. It would just stay.
Oh yeah, it's a max heap. It wouldn't swap. It would just stay. And then we just move like down the indices. So this is the first one we look at. This is the second one.
Mm-hmm.
So maybe we go to 3 here. And then once we get to 3, what are we gonna do? We're gonna want to swap it, or we're gonna want to get it to the right place. So it's bigger than 6. So maybe we could just swap 6 here. Or 6 is bigger, and then we'll have to swap it again and kind of get things into the right place.
Mm-hmm. Okay, so basically you're saying like I'll go on every element and just like bubble down in some way.
Yeah, and then 1 has nowhere to go, and then we go
Mm-hmm.
to 4, and not actually, yeah, that worked. And maybe like it amortized to O(n) because things get into the right place,
Mm-hmm.
something like that.
So I think
That's
it's
one way to-
actually, I think, and this is not super intuitive, but as far as I remember, it's actually you start at the bottom and you do this thing. And then that's like a better structure. I also don't remember if it's bubble up. I believe it's bubble down. So basically you start at every element and you bubble down, but you start at the bottom and that makes it faster, if that makes sense.
Okay, so you just start and then you go like this way.
Yes.
But for every element, you're gonna want to perform the operation.
So you actually don't need to perform it on the very most bottom layer because it's already at the bottom. So we can handle that if you want to as well. Like for the bottom layer of the tree, you don't need to do anything because it's already at the bottom, right? Like there's no swapping. But you can also call it in every element. I'd say that's fine. I don't
It
really
makes
care too
sense.
much about the
It makes
implementation.
sense. That makes sense. Yeah. Like it'll be no op because it's not looking at anything. But then 5, all it needs to do is really make one swap.
Yes.
It kind of will just need to make one swap
Yes.
with the one that's larger, and then you just do that for every single element. And since you start from the like at the bottom, yeah, you could assume that every it's like kind of caching. It's like it's like DP kind of because you already know that the heap invariant holds for like my children.
Mm-hmm.
So if I just swap with myself, that invariant will hold as well.
So
Kind of like
actually,
a bubble sort.
thinking about it some more, I think it's actually like I'm not 100% sure, so you can tell me what you think. I think you actually do that, but then instead of bubbling down, you bubble up. Because if I bubble up here, then this will be in the right spot, and then that like the element that needs to be here will be correct. But if you bubble down, then what will happen is like maybe the thing at the top actually needs to bubble down all the way, so then it won't be in the right spot. You know what I mean? So I think the algorithm. I mean, I could look it up later. I don't really care which one you do, but I think the correct one is you start at every element except for the bottom row, or the bottom row if you want to, and you bubble up.
Okay, you try to bubble this like each one up to the top.
Yeah, so I guess you could start at the bottom row. I don't remember for sure if it's like bubble up or bottom. Like I honestly don't care which one you do because I don't remember off the top of my head. Like I think for this one you have to think about it, but I think anything, whatever you prefer, is fine with me.
Yeah.
And
How much time do we have left?
Yeah, so we have about 20 minutes.
Oh, okay. So let's look at. I mean, we could try to derive it and make sure, or we could just go ahead and implement it. And then
I think you can derive like on your like you can just look up what it is exactly, but we can just implement one version of it. And I think if you do it the wrong way, it's nlog n, which is like whatever, it's fine. Because it's hard to derive it because you have to check a bunch of stuff. Like you basically have to make a big tree and test a bunch of stuff and make sure it works. You can also actually, so for this, let's do this. Let's actually use the AI assist to ask what's the actual algorithm. I think that's going to be a good case of this. But it's one of those. Like you either bubble up or down from the bottom. Okay, well, we don't want the code, but
Oh shoot. Okay,
uh,
wait. Let me add the next one.
yeah.
Give me the algo for Heapify without.
Okay.
What was saying?
So you index elements that largest is the current index. Compare. Okay.
So do you start at the?
Let's see. So
Do
this is
you
saying,
start
yeah, you can
at
ask.
the top?
I'm not convinced if this is going to be right, but we'll just go with whatever it says. Also,
Yeah,
this is
it's just a mini model, right?
let's up our model. Hold on. All right, there we go. We're gonna do an upgrade. Okay, maybe ask one more time. Can you like delete the chat and ask again?
All right.
All right. We'll confirm it with a better model because like this thing is gonna
Yeah.
like be whatever. Okay, this is
Do
fine.
I start from the top and
do you bubble up or down? Yeah.
or bottom and bubble up?
Okay.
Another interesting heap question is like increment and decrement, like randomly within the tree.
Okay, here we go. So starting at the bottom and bubble down. Okay, so I was I didn't
At the
remember for
bottom
sure.
and work upward. Okay,
we go.
bubble down.
Yes. So this is what I was saying at the last non-leaf node, but I'm
Okay.
fine with you just starting at leaf nodes and bubble down will just be a no-op. I think that's totally fine.
Do you bubble all the way down or just swap?
No, you definitely bubble. Oh, I think you bubble all the way down. Let's find out though. Yeah, all the way down. Okay, there we go.
Interesting. Okay.
Okay.
All right.
Cool.
So I'm just gonna like copy and paste some of this.
Yeah.
So I'm gonna.
So ideally, what I would recommend is you have some shared functionality that you might want to extract out. If you can think about what that is.
Probably like the bubble down.
Yeah. So like think about what that would look like if this was like production code. So ideally, we don't just copy paste like 20 lines.
Yeah. Let's do Heapify.
Okay.
And then this is kind of the prompt here, and then Heapify. So what we're gonna do is maybe like what do we think we're gonna pass into? Pass into it like the array, and then we set the state as the array, and then we Heapify that.
So I think what we can do is in our init, we can take an array and then we can just call Heapify right away. If there's an array. And if it's empty and calling Heapify an empty will just be a no-op. So you can just call Heapify in the init and take an array as an input. You can say like, yeah, array equals like empty array. Yeah, exactly. I think that works.
Okay. And then we'll just like Heapify to just ensure if they want to initialize
yes.
state. Or we're gonna do self.heapify of self.state.
Yeah, and if it's empty, this will be a O of 1, so that's totally fine doing that.
Yeah, or we could just call Heapify exactly. And it doesn't even know.
Yeah, exactly.
But so what we're gonna do is we're gonna want to pull out. So we're gonna bubble all the way down until the property is satisfied.
Mm-hmm.
So the property is gonna be this is the bubble down code.
Mm-hmm.
And this is the bubble down code, and we don't care about the return value. So what we're gonna implement like a def bubble down.
Mm-hmm.
But we're gonna want to start at a random index.
Yes. So you can also give this a oh yeah, I guess you can, this is fine.
Just kind of like a bubble down.
Mm-hmm.
And then we could do self dot bubble down. Add an index. Right.
So with heap hop, oh yeah, our index is 0 and we just called. Yeah, I think that makes sense. Yeah, we bubbled down. Yeah, I think this makes sense to me. We can also just like once we have this running, we can just rerun our test that we have already. So
yeah, we can do. Yeah, we can. Let's just run this right now. Make sure it's working. Should say 2 and 1. All right, looks good.
Okay, yeah.
And then what we're gonna do is we're gonna Heapify. So what we says. Let me look at the AI sys.
Mm-hmm.
Start from the bottom. So we're kind of good. We're just kind of want to reverse. So for I in range, oh, it's gonna be from the bottom. That's gonna be
from the bottom.
yeah. It's gonna be interesting because we're gonna want to go. We're gonna start at 8. Oh no, but or let's go here. I think we could just go reverse. 0, 1, 2, 3, 4. Yeah, we could kind of just like do a reverse while loop from the
Mhm.
length of the array to 0.
Yeah, that sounds correct.
So we say for I in length of the self dot state -1 -1. What we're gonna want to do is like self dot bubble down like the I.
Okay.
I think that would just work.
Okay, yeah, we can give it a try. So you can make it with a like an array with whatever and see what happens.
Do largest equals heap dot heap pop. Second largest equals heap dot heap pop.
Cool.
Just print.
So maybe print the heap before popping, and then after.
Okay, we could do print heap.
Yeah. So what do you expect on 118, and then if you print at the very end?
So on 118, we kind of expect the largest element to be at the front. We don't really know the rest of the elements.
Yep.
Well, we can derive it by looking, but we just know
Yeah.
that. And then this should bubble up to 3,
Mm-hmm.
and this should bubble up to 2.
Yep.
If it worked.
So let's see which one is which actually. Okay.
Oh shoot!
So the
Let me
top.
delete the popping.
Oh, that's right. Okay. Yeah. Did we call Heapify in the init?
Oh no, we didn't.
Okay, that's probably why.
So
Okay.
let's just do tests, and then probably what I'd do is like actually turn these into proper tests.
Mm-hmm.
So we start 1352. We
Mm-hmm.
put the heap. Heap says 1352.
Mm-hmm.
That doesn't look right.
That doesn't look right. Yeah.
Do we even call Heapify? Oh no, what is this doing?
Oh, so look what you did here. It's like a pretty obvious mistake, I think.
Yeah, bubble down. If I'm bubbling down on I.
So how does this work?
So it's going for the length self dot state -1. Oh shoot.
Yeah. So I think this is like I can just point it out. Okay.
Yeah. 5, 3, 2, and then the largest. Damn, let's see. Yeah, 5 and 3 is the largest. Looks like it's working.
Okay.
So
okay.
expect 5 at front. Yeah.
Okay. So there's one last thing that we can try to do. I think it's doable. So basically right now we have a max heap. But ideally we want a heap that has a custom comparator. So for example, let's say I actually want a min heap here. So I want to be able to like pick what kind of heap I want. So what I want to be able to do is pass into this function a comparator, like a lambda, like let's say we like lambda x, and then or lambda that takes like I don't remember the format of the lambda, but let's say it's like this, and it returns like a less than b or a minus b or whatever, some kind of custom comparator, and then that way, like maybe I have a tuple and I want to compare by the second element, maybe I want a max, maybe I want a min, maybe I want whatever. So how can we modify our implementation to handle that?
Okay. Let me look at the code.
Okay.
let's see. Let's just like collapse these to just make sure.
Mhm.
So what we want is custom comparator. Let me write some notes. So do we want that? We would probably want that when we're initializing the heap then, right?
Yeah, so assume we give it a comparator. Yeah, we give it a comparator, and we have to provide this comparator.
Okay, this will probably be like okay. Then we're gonna have to use that comparator when we're actually comparing stuff, which is pretty much
Yeah, so where do we do that?
okay. So what we're gonna want to do is like, do we have to specify? What I would say is, if we want to specify comparator, the comparator is gonna have to take in like an A and B,
Mm-hmm.
and then it's gonna write some. It's gonna have some logic to compare A and B, and it needs to generate like a total ordering. So we need to actually be able to compare the elements. I think
Yeah,
we just
so
need,
you can do
yeah.
this whatever way you want. It can be a Boolean. It can be like 0, 1, -1, like a sort. This is up to you. Whatever works is fine.
So what we could probably do is just we could just store the comparator
Okay.
in like a state,
Mm-hmm.
and then for each one of these, we would just like replace with the comparator. So like wherever we do the comparators, we pass in the value, and then something like this,
Mm-hmm. And this
right?
is
And we
telling
do.
us what, like, so what will a comparator look like? Will it tell us if value is like greater than the parent or less than, or?
It'll return a boolean,
Mm-hmm.
right? Like true or false if one's less than the other.
Yeah, yeah. So basically, what I'm asking is uh, like which one would be less here? Like if this is true, which one is less? Like
We
what's your
want
actual comparator?
we want to return true if it should swap. True if it should
Okay.
swap. Let's see.
Okay. So then
Where am
basically
I?
we're implementing the okay, sure, that's fine.
True if we want to swap, right? So if this was a min heap, we'll just return true if it's greater than the other.
Okay,
True
got it.
if it's a max heap, we want to return true if we want to swap.
Okay.
So the comparator would want to return, yeah.
Okay, sure. And we need to pass
So
in, so we're passing the first value, and then the order here also matters, right? So basically we're passing the current value and like what we're trying to swap with. That's our comparator syntax.
yeah, I
Okay.
like this is kind of a custom one. I'm not sure what the actual
So
like.
actual
This is probably
comparators,
standard. Yeah.
like typical is like you do some lambda AB, and typically it gives you a integer, but a boolean is fine. So typically this would be like true if a is less than b, maybe false if not. This is like pretty standard. And then sometimes you want to know if it's equal. In the heap, you don't really care. So if you care about it, you can do like lambda ab, and it can return like -1 if it's less, 0 if it's equal, and 1 if it's greater. That also is fine. So whatever you prefer, that's reasonable is
Mhm.
fine.
Okay. Yeah. So I think all we'll need to do is throw in this custom comparator into all of these checks.
Okay.
So and then we'll switch up the
Mm-hmm.
we'll switch and so yeah, something like that. Oh shoot, just self dot custom comparator. So now we have the comparators checking,
Mm-hmm.
and then we would just have to store that in the state. And then now we just need to implement the comparator.
Mm-hmm. So let's add that to the test.
Yeah. So what we do is we have the heap. What is the heap? It takes in a comparator.
Mm-hmm.
So let's just say the comparator is like, we can turn this into a Lambda function after.
Okay. Yeah, I'm not super familiar with how functions are passed in Python, so whatever works is fine.
So we want to return true if A is greater than or equal to B.
Okay.
That will maintain our last one. Like our last code.
Yeah, that makes sense, yeah. So it should basically be all the same. Heap object has no attribute comparator. Did you make a self or something? Comparator. Okay, so it's breaking and bubbled down, I guess.
Wait, let me
Did you
see
misspell it or
something.
something? No.
No, maybe. Let me just, let's see. Bubble down. So it's calling Heapify, then it's calling bubble down 89. Heap object has no attribute comparator. But I am. Yeah, oh, so I just need to initialize it before. Sorry.
Oh, okay.
Like right away.
Okay, so what do we get now? We got nothing. Oh, nice.
There you go. Yeah, so that's largest. If we want to turn into a min heap, we just do like this. That should return like, index out of it. Oh wait, I need to fix more conditions.
Okay.
Yeah, because this float, that's what makes it harder. Because this.
Oh, you have it hard coded.
We have it hard coded on.
Yeah. So the proper way to do it is check. Oh yeah, you need to use comparator.
If these are none values, yeah, I'll just basically in the compare, if one is none, then you just have to return the other.
That's fine. Yeah, that makes
something like that.
Yeah, I think like a production one would be like checking for actual index and figuring out some better thing, but I mean that's a lot of stuff. So yeah. Okay, I think we could stop here. I think that's totally fine. And yeah, basically, if you do modify that, then you can use it for like tuples. You can use it for whatever you want. You can do min, max, any element you want. So this is how it is in a lot of other languages where you provide a comparator, and then it's like very convenient. It's not just like min, and then I have to like negate stuff and whatever.
Yeah.
Okay.
Makes sense. I think I just need to figure out how to not hard code that float infinity, and then it could just easily turn into a
min. Yeah. I don't think that's because our initial constraint was max. That's totally fine. Yeah, we could stop here, I think.
Nice.
I know you can like change that. Okay, so yeah, so what did you think about this one? I never asked this before, so curious of your thoughts.
I think it's a good question. You just have to make sure there's no bugs, because if there's a bug, it might be hard to fix. So I think I realized I was going a bit slow. Should probably check the time. But I was just making sure I didn't get any bugs.
Yeah, well, actually, for what it's worth, I think this one is pretty reasonable to bug fix, because like you had bugs and you fixed them all, you know. So
yeah,
I don't think there was anything like for DP or some crazy number. It's like, how do I fix this? I think here, like it told you wherever you were indexed out of bounds, and then you could print stuff. I think you had very good like you know how to debug using like error messages and like where to print and all that stuff. A lot of people can't do that, and you can like read the stack and say like this is what's wrong, and so I can fix it. So basically, I said so you were familiar with like a heap. You discussed like how to do this. You got the time complexity correct, and I think I would expect people to know how heap push and heap pop works. But Heapify is totally fine if they don't, because it's very rarely used. I think in some languages it doesn't even exist. So I think it was fine for me to like tell you. And honestly, I didn't even remember exactly. I was like, I know roughly, but I don't know exactly. And it takes a while to, like, you basically have to write a big heap and try a bunch of stuff and be like, oh yeah, this is the one that is linear time. So I think an AI assist there works. And I think you also are pretty good at like what needs to be private, what needs to be public. It would have been good if you took the bubble up, and you also would have made it like another helper, because it like ideally in your like main stuff, you want it to be easily modifiable, and like this bubble up is like business logic that like I don't really need to know in a heap push.
That's true.
So if this was like production code, you would have it separate, and then you want to make it in a way where you can add more functionality. So yeah, I guess this other thing is okay too, because I just said let's make a max heap. So I didn't say like let's make a max heap and then we'll make a generic later. So I think it's pretty reasonable. And as long as you understand like how to fix it later, that's totally fine. Yeah, I definitely think your speed, it was a bit slow, but you do a very good job. Like I feel like there's people that are like algorithmically insane and they just make mistakes all over the place. I feel like you're algorithmically like pretty solid, but then your like actual software engineering is like really good. Like you stop and you figure stuff out and you can like figure out all the edge cases as you go and you don't miss a lot of stuff. Like I think the only stuff you
Nice.
missed was these index out of bounds on the parents and the children. I actually didn't even recognize it on the parent. I didn't write that. I recognized it on the children for the bubble down. But that was it. And I do expect people to have coding mistakes in this because it's like there's a lot of stuff. And also you showed that like Python other than just like leetcode, because a lot of people are like, oh, I need to write a class. I've never done that. Like where it's in leetcode, so like I just use that, you know.
Yeah.
So if you know like the repr and length, like basically I'd expect people who code in Python to have like as good Python knowledge as me, because I don't code in Python. I just use it for only DSA. And I think you have like better Python knowledge than me.
Nice.
So yeah, and then yeah, you were familiar with the stack trace. So when you had a bug, like a lot of people can't read the bug, and then they're like, "So where's the bug?" And then I have to like it's pretty obvious. You know, it tells you exactly what function calls what, and you were able to like add print statements in the right places and then debug pretty well, and pretty quickly. So basically, I gave you for DSA and problem solving, I gave you a 4 out of 5 because you didn't know Heapify like at all. Ideally, you would have known like roughly or at least time complexity, but it's also
Makes
pretty
sense.
rare. I think your communication is very good. Like I knew exactly what you were doing, and then you drew stuff. I actually don't like the CoderPad drawing. I wish they let you just have like Excalibur open and like a CoderPad like side to side, so it doesn't cover the code. But yeah, it's kind of a pain.
Yeah.
But for what it's worth, like you used what you had and it was good. And then yeah, your speed was 4 out of 5. Like even though it was kind of slow, I guess you still finished like everything I asked you in an hour, and there was a lot. And I probably, if I was to ask this for like an intern or new grad, I probably wouldn't even do the Heapify. I would just do the first two. And let's see if there's anything else. Yeah, so you had some bugs, but you basically caught them all. And like I think I expect some bugs here if you have to run your code. And then you had some small stuff like you had a less than instead of like a less than or equal to, but it basically was the same thing, or less than or equal to when it could have been a less than, but it was like I don't really care. So yeah, so I would say this is like somewhere between like a solid higher and strong higher. Because like the thing that I care about the most, I feel like, is like, yeah, the thing I care about the most is like, can you explain what you're doing? Can you figure out bugs on the fly? And can you like see problems you've never seen before and then figure out solutions? So like that Heapify you've never seen before, and you just like AI'd, here's a rough algorithm, and you were easily able to modify your code. Like you didn't have to make these huge changes because it was like good to begin with. So I think that those are good like questions and practical problems where you ask something and you ask a bunch of follow-ups and you're like, do they have to delete half their code now because they wrote it in a bad way? Or I think for you literally just took one function, put it in another one, and wrote like and added another line, and you're like, okay, I'm done. And that's like a good sign that you know how to actually build like decent code. Yeah.
Nice. I'm super happy to be able to like get a pass for Alpha Labs.
Yeah,
I know
yeah.
a lot of candidates have not been passing lately,
Yeah.
except for like the last few cracked ones. But thanks for taking the time out to interview me.
Yeah, no problem, dude. No problem.
Yeah.
Okay, yeah. I will catch you later.
All right, man. See ya.
See ya.
Peace.